Um, Hi, everyone. My name is Didier Lopes. I'm the co-founder and CEO of OpenBB. And today I'm going to talk about how to create an AI-powered financial analyst with OpenBB. So it's going to be a fairly technical talk. Yeah, I hope you enjoy. Yeah, I'm also going to rely a bit on the slides. So if you want to go more to that side, I'll probably recommend it so you have a better view of even the code. I show a bit of the code of how we built it using LangChain and OpenAI and OpenBB, obviously. Yeah, let's get started. So first of all, I want to talk a bit about the OpenBB ecosystem. So we are, what do we do? We are an open source financial company. We have an ecosystem of products. We've got the platform at the core, which we released a new version last week. And what it does at the core is very simple. We connect data sources together. We standardize the data to make it easy for users to build tools, to have access to financial data, to play with it on a notebook or build an app using Python if they are just playing with the data, but if you want to build an app, a web app, you can also do it. And so we make it very easy from that perspective. And we created an ecosystem that is like a positive game. So data vendors want to be available from our platform, and at the same time, users benefit from having access to those multiple data vendors. Then we have the terminal and the OpenBB bot, which the architecture is open of the bot, and the terminal is fully open source. At the end of the day, it's a command line interface that provides you access to all that financial data straight from a terminal that you can use at home or anywhere, really. And then on your left side, you have the Terminal Pro and the Excel add-in, which is our first enterprise product. And the Terminal Pro was actually released this week, the early alpha version. So yeah, exciting time. But today I'm gonna focus on the platform because that's what we use to build our AI-powered financial analyst. And so yeah, let's get started. So first of all, we basically built a roadmap of what we thought that, OK, what does it look to go from stage 1 into stage 5, like the autonomous vehicles have? We created these different stages in terms of what does a financial analyst needs to do. So the first stage for us was, OK, knowledge retrieval. That's fairly easy. ChatGPT can do most of it because basically the models are trained on so much data that it can know financial questions. So you don't need to go into Investopedia to get more information. You can just ask what is the PE ratio? What is the price to book? These type of questions. So that's stage 1. That's fairly simple. Stage 2 is data retrieval. So basically that means that I should be able to provide my LLM with data and ask a question that is within that data. And that's also fairly easy. Even ChatGPT can do it today. The next stage is autonomous data retrieval. So here is a bit more complex. I think it involves function calling. So basically it involves the agent having access to financial endpoints and not having the data right there, but being able to call an endpoint to have access to that data to answer the question. So that the difference between the previous one is that the data is external, so it's not right there. The fourth one, and that's the one I'm going to present today, is actually being able to solve a complex workflow. And what do I mean by these? I mean not just doing one function calling, but multiple that involve reasoning in between. So this is something that is fairly complicated, as I'm going to present to you in a few minutes. And then finally, we have a fully autonomous agent, which is what we are, fully autonomous analyst. And this is what we are aiming at. And here we really want to put our hands off, and we want the analyst to do the entire research report for us, which involves function calling, it involves understanding how to interpret the data, involves very likely fine-tuning the model based on financial data. And so this is one step ahead from where we are. Today I'm going to show you the fourth one. And I don't know of anyone doing this type of work apart from OpenBB, which is a very exciting thing. So, OK, what types of prompts? We started basically by, OK, this is our goal. So let's go from there backwards in terms of what we need to do to achieve that. And so we selected 2 prompts. And those prompts are very different between each other. So the first one is do my workflow. So this is basically an analyst that knows what they want to get done. And so I'm just telling my agent that I want this to get done. And this prompt does check what are Tesla peers. From those, check which one has the highest market cap. Then on the ticker that has the highest market cap, get the most recent price target estimate from an analyst and tell me who he was and on what date the estimate was made. So there's no well, what I want to say is deterministic. I can check whether the answer is right or wrong. I just want the agent to save me time, because this would take quite some time with all the steps involved. It relies on previous outputs. You need to go into each endpoint and check for the data. The other prompt is much more creative. So I actually want to learn from the agent. So I ask, perform a fundamentals financial analysis on Amazon using the most recent available data. What do you find that's interesting? So I'm giving the freedom to the agent to tell me what I should look for. So I'm not asking anything in particular. I actually want to know how the agent thinks about it. And so these are what we started, and I'm going to talk with you over the architecture that we implemented, what the agent is doing at each step, all these open source. I'm going to share the notebook at the end with you, and we are also going to see the results at the end. So yeah, let's get started. So the OpenBB platform, the reason why it works so well is it's really easy to have access to data. So you do from OpenBB import OBB. If you use Python, you log in into your OpenBB Hub account. And the reason why you want to log in is because you can manage all of your API keys from the data providers that we support on our platform. And then you just have one personal access token that has access to all that data. You can upgrade the data providers on the data side, and we just work with that because at the end of the day, it's just an API key. And then you go access the endpoint. And we have hundreds of those. So we standardize it. So if you want different data vendors for the same endpoint, you get access to the data in the same format, which means that you can really focus on building and not worrying about the standardization of the data or if there's going to be data at the end or not. Why am I saying built with Pydantic? So Pydantic became super famous recently because it's a data validation framework, and it basically allows you to check for the validity of the data structure that you have. And so what this allowed us to do is that right now, instead of just having an endpoint that you have access to data, we can check whether the inputs you are using follow our guidelines and whether the output follows our guidelines. And the reason why this is so good is because agents need this. They need to know the structure in terms of inputs. They need to know the structure of output. And this is going to be very critical in terms of when we provide these function calling capabilities to our agent. And so what you can see here is we have these endpoints. It's called coverage.command model. And then you can select the command, the data that you're interested in. So in this case, I'm showing equity, price, historical. Then we've got the OpenBB, which basically means that this is the default data that you have. So in terms of input, which is the one above, and output, the one below that you can see on the slides. And so let's say that you are interested in a different data provider, like Intrinu, Polygon, FMP. You replace the OpenBB by those names, and you will get a similar standard of what you can expect. And so we made it to be very easy to switch data providers if you want to access another data provider, or if you are paying for a premium service, you can just hook it up and use it. So this is for the creating OpenBB endpoints to use, right? But how do agents are aware of it? So what we did is we basically set up OpenBB tools for retrieval. And think of it as a suitcase and someone going to go for a job and having tools at its disposal to use. And so we made it so that the agents have access to not just the endpoint that they can call, but they have access to the doc string, they have access to the inputs, they have access to the outputs. And so it knows that if I'm asking what are Tesla peers, it knows that it needs to go into the obb.equity.comparison.peers endpoint, because it knows that that's the right endpoint to return the peers of a company. And so we made that super easy using LangChain. Yeah, that's what we're going to rely on. And so what you can see here on the function, you see a map OpenBB collection to LangChain tools. And we selected a few categories: fundamentals, compare, and estimates. And so we gave these tools, and these are a collection of 20 to 30 commands. And we tell, OK, agent, this is all you have in order to access. But you decide what you want to access, and we're going to go through it together. And then we basically just put it into a vector store. And the reason why we put it in the vector store is an n-dimensional space. And we basically are going to match a query using Facebook AI similarity search in terms of how similar it is with the doc string based on what we want. And the best match will return the best tools, which our agent will be able to use. And so, OK, how do we start with our AI-powered financial analyst? First of all, those prompts are complex. I don't want to solve it in one go. So the first thing we do is we create subtasks from it. So let's say your manager asks you to do something. What you're likely to do is to create subtickets for it that basically make it easier for you to do each task individually, and then you combine the output, or at the end of the last task, it's done. And so that's what we do. And so you can see here the prompt, but the important thing here is keep it simple. So you have the list of the prompt, the instructions, and then at the end you can see that we expect an ID, a question, a query, and a depends on. So the ID is just to identify the order. The question is the subtask, so the simplified subtask. The query is very interesting. So the query returns me one or two keywords that relate the most with the subtask at end. And the reason why we did that is because the performance improvements in the tool retrieval process were very, very big. So think of the subtask of check what are Tesla peers. I don't need the Tesla. I don't need the word check in there. That's noise, and that was affecting the process of tools retrieval. So that basically gets converted into like peers, company peers. And so that makes it so that when we go grab the right tool for the job, we have a much better match. Then we have the depends on. And this is important because we want to know if what we need to get the job done relies on a previous output or not. And so, OK, I added this on the prompt, but this is enough? No, it's not enough. So what we do is we use, again, a Pydantic data model where we create the structure, the JSON structure that we want the model to output. And you can see here that it has the same ID, the query, the string, and then the depends on. And you can see we set the types. And so if the model doesn't return something that goes along this logic, it will try it again a couple of times until it gets it right. And so you can see this is how the code looks in LangChain. And you can see that code there, Pydantic output parser, where we want to make sure that the format is the correct for our agent. The next step is the tool retrieval. So here is where we use the query words that I was talking about. And so what we do is very simple. We want to get the best tools for the job. And so empirically, we found that this score threshold, the similarity score threshold of a 0.65 gave a good result. So that means that if I'm looking for Tesla peers, if I use the word peers and I look for all the endpoints, for 0.65, I might get 3 or 4 tools, and I will give all those tools for the agent later on. But if I get less than that, that means that the matches weren't as good. So it means that in terms of this n-dimensionality plane, I don't have something as close to it. So what we do as a fallback mechanism is we get the next best 2. So we know that they are below this threshold, but we assume that, OK, it must be one of these next 2, right? And so this is basically so that it doesn't happen that there's nothing above 65, and then you get to a job, you open your suitcase, and there's no tools for you to get to work because you can't access the data, right? And yeah, this is how it looks. We basically, you can see that we use these get tools, and then we use that query. There's like trick that we use to basically get a better tool retrieval. Subtask agents. So now that we have, for each of these subtasks, we have the suitcase to get the task done. In this case, what we do is we provide this case to one subtask agent. So each subtask agent will be responsible by one of these tasks, but they won't do it simultaneously because some of these prompts depend on the previous ones, and that's very, very important. And so, but we still divide to conquer. So we create an agent, and the agent basically has access to the tools to solve the task. He has access to that, like access to this subtask. It has also access to the list of dependencies. So if it depends on a previous output, we're going to wait for that output to give it to the agent. And we also provide it with the main prompt. And that is because sometimes just a subtask is not enough for the agent to answer it right. So let's say that, I don't know, this is probably a stupid example, but you get my idea. If I'm in the shopping and my mom gave me a list of things to buy, and I know that I need to buy ketchup, and I may be like, OK, what is the ketchup for? So I want to know the context of like, what are we doing with the ketchup? It's kind of similar. You get the idea. And yeah, this is how it looks in terms of the implementation. So you can see that we are providing the tools for the subtask agent. We are combining everything together. And yeah, the subtask agent responds each of these questions in terms of a string right now. So this time, we don't want a JSON. We want the final question for each subtask. And then finally, this step is very simple. What do? We combine all of the subtasks inputs, we combine all of the outputs, we combine it all together, and we give it to a final agent. We give also the main prompt, and we say, based on all of this context and based on the main prompt, answer my question. OK? And here's the code if you're interested to see how it looks like. So yeah. An architecture recap, and then we can go into the results. This is what we are dealing with. So you have the main query. We do the task decomposition first. That list of keywords that is associated with each subtask is what we use to retrieve tools. These retrieve tools goes with the keywords into these tool embeddings that is in the vector store. And this is only possible because we used OpenBB. We created OpenBB tools from OpenBB platform, and we used LangChain in terms to do that mapping. And then we get the best tools for each of the subtask agents. The subtask agents get that tools, they get the task at end, and they get the main prompt. They answer each of it individually. If they rely on another dependency, you can see that there's that reliance, like the arrow. And then finally, we give all of this to the final agent, and he responds. So what does this look like? So these were the initial question. As you can see, this is a very tricky question. So I asked the Tesla peers, then it needs to go through each of those peers, of those companies, and it needs to go into the market cap. And the interesting thing is we actually don't have any endpoint that returns the market cap directly. So it lies within the overview endpoint. And the reason why it works is because we added the trick that basically on the docstring of each function, we add the output fields with a bit of some processing to make it, like, for instance, replace underscores by spacing to make it more like natural language. But that improved a lot in terms of quality. So the LLM will know that you will know where the market cap is, even though there's not an endpoint market cap, but it's a field within an endpoint. And then we need to reason about which one has the highest value. So we need to store that data in memory and understand, OK, from all the market cap that I saw, this one is the one with the highest. And then I need to hit another endpoint to get access to the estimates and then understand who it was. So it's fairly complex. And so when I asked that to the agent, this is the reply I got. So I got that the peers of Tesla are XPEV, LI, Rivian, blah, blah, blah. Then the highest market cap, it got it right, which was General Motors. It tells me how much it was and when it was last reported. And then I get that the most recent price target estimate for General Motors was Daniel Levi, and it was of $37. And I even get the date, which is something that I asked. So fairly impressive stuff. We got this like on the first try, which we were like amazed that he was able to do this. It's crazy, the time we live in. And then we checked. We was like, OK, this is too good to be true, right? No, it's literally correct. We literally compared with the data. We did the job manually, and it took us way longer to get the data manually, because here I'm just showing the peers. I'm showing the General Motors. But I had to go through each of the peers to get their market cap in order to understand actually, OK, which one is the highest. So even on the fact checking, I had already more work than the agent had. And it was actually fun because we released our Terminal Pro, an early release earlier this week at MindsDB, and I showed these in a demo. And it's literally, you wait 2 minutes and you have the agent performing like this. It's insane. The other one, again, there's not going to be a right or wrong, but you'll see that the response is pretty good. Like, for me, that I'm not like a financial person in terms of like education, like having that, I wish I had that like 2-3 years ago when I started my investment research journey. So this is the example of the output. It's not just, it doesn't just simply tells me about the stock price. It knows how to understand how Amazon is performing in terms of its peers. So this is either on the model that it knows through the weights, or it went to an endpoint and got access to that data. And so this was actually the part 1, and then there's also this part 2. And the thing is, this is not the end. So the LLM doesn't stop here. I can keep asking him. I can do like clarify this last bullet point. What does this mean? Or, you know, now you did Amazon, and what if I want to ask about Apple? Like, how does Apple compare with Amazon? So we live in a very, very exciting time. And to be honest with you, the platform, we released it last week. We spent like 6 to 8 months working on it, and to be able to build that OpenBB tools, because we are betting big that AI is going to be the future, and companies that don't adapt in the financial industry are going to be left behind. And plus, we have an open source core, and so we want everyone to be developing with us, helping us build this amazing like standardization framework that data vendors can incorporate their data, and everyone can just focus on building and not have to, you know, go into these data providers and just read their documentation and go to another one and manage that. We want to focus on that for users. And so, yeah, this concludes my presentation. I have 13 seconds, so this is where the notebook is available. I want to give a shout out to Michael from our team. He joined recently as head of AI, and he's been a big push in terms of like creating this OpenBB agent. This is fully open source, so we're welcome PRs, we welcome like discussions, and we just want to make like a better financial agent for the industry. And yeah, thank you for everyone to be here. Questions? If anyone has any question, otherwise. Bob?
Your open source project, how's it going? How many contributors do you have on this one?
We have 215 contributors right now. We, I think, are probably like 80 or 60 stars away from 25,000. So it's been interesting, the growth of the project. We see peaks of interest in terms of time, but now it's pretty much like a steady growth in terms of adoption.
And among contributors, this is true for any group of humans, some people are dramatically, not twice as important to you, but 10 times as important to you as others.
Yeah.
Have you identified contributors that you think are your
Yes.
all-star contributors?
We hired those. Yeah, we hired most of the people that become like a big push towards the financial side. They keep on adding features and important features for the future. We identify those. The others, we can sometimes check from their GitHub pages that they work at the JP Morgan, Goldman Sachs, so we keep like connections and we keep them close. But yeah, you have the challenges of the open source, which is like, and I think particularly when we started as a first-time founder, we got a bit pushed from all the places. So the terminal, someone would come in and say, I want to do execution. Someone would say, I want to do portfolio. Someone would say, I want econometrics for my course. And because we're technical people and we can do it, we started going a bit in that way. And so, yeah, we were like stretched thin. I think now we're much more focused, for instance, and we say no when we don't think that's the right thing to do. And also, so now we are actually really focused on the platform and building that basis on, okay, is the data access, this is what we focus on, and people can build extensions, is standardizable, and so everyone can contribute and even either keep it private for their own firms, or they can make it open source accessible to others. Thank you.
By the way, for your enterprise clients or like companies trying out, have you tried experimenting with open source models for OpenBB?
I have not, actually. We focused on OpenAI because it was the simplest and fastest to use, but we do want to do that. Our next stage is actually to try fine-tuning because we believe that it can, like if he has the weights and already understanding like, financial statements and stuff, like the performance boosts are going to be big, but that's the next stage. Yeah.
Thank you.
Yeah.
Which other tools do you think would work with OpenBB? You mentioned LangChain as an example.
Yeah. So LangChain, actually did a demo about this week, like the LangChain, LumIndex. We are doing chat with documents on our Terminal Pro. So basically, you can upload like a Word document, a PDF, and you can chat with it, ask questions. Also, MindsDB, for instance, if you do machine learning on the SQL, we allow you to integrate with the Terminal Pro, or even Nixla, which released the TimeGPT, foundational model for time, and they announced like a partnership with Microsoft recently. We can incorporate that onto the Pro fairly easily in terms of trying to estimate the revenue of a company. So yeah, it's fairly customizable in terms of what we built. Yeah. Thank you. Okay, I think that's it. Thank you, everyone.